This is Deshawn Johnson. I'll be going over the digital sampling slide report. Um, the primary objective of these experiments is to familiarize yourself with digital data acquisitions of time varying signals. And this was achieved by doing different tests with and experiments with the DAC, which was our LabJack T4. So key concepts was waveform and frequency. Using Fourier series, we got to analyze uh, those frequencies with math. Not analyzing. Also, sample theory and aliasing, and then digital data acquisition systems. Like I said, LabJack T4, and my personal experiment, which was basically how does a sound source dropping using different frequencies impact the amplitude of the waveform comparing the DAC and the microphone. Materials: LabJack T4 microphone, aux to analog adapter because I'm using a MacBook, GCA AE simple DAC, screwdriver to install the wires to the DAC, and my iPhone as a sound source. Tests and experiments. The first part of the lab was to identify waveforms at different frequencies. How did they look, and identify what they are. Then we use microphone usages, which just was testing if our microphone works to see if any voltage is going through. And then lastly, my own experiment, which was the Doppler effect, testing the Doppler effect. And my own experiment was just to analyze the waveform frequency and amplitude as the sound source falls past the microphone. I use like 4 different wave frequencies, and then the procedure was to I measured the amplitudes of the sound waves at different frequencies as a source of sound falls at 72 inches and having the DAC located 36 inches. And the success criteria was just to be able to plot the output voltage versus time as the sound source falls. Some results that we got from that was waveform identification, which was there was 11 tracks with different frequencies and different peak frequencies at that. And then each one had different waves. Well, not each one had different waves, but there's different waves for different tracks. So as you can tell, there was sine waves, triangle waves, square waves, ramp waves, and a little bit of between, multiple sine waves and things like that. We calculated its principal frequencies and other peak frequencies. There were some possible errors, which could have been user error because this is our first time using a DAC, and again audio jack because I'm using a MacBook, so it might not have worked all the way correctly. Results from waveform identification. We did sampling rates of aliased frequencies using FN equals Fs divided by 2, and if it was greater than the frequency that we receive, then it was an aliased signal, but we didn't have any of those. And table 3 went on to test the cutoff frequency for a sum of sine waves, which we got 2000 hertz, and anything above that 2000 hertz, we realized that there would be a cutoff. And then calculated relative response of the microphone system. And we just did that by doing power from microphone at each tone frequency and power at the same tone frequency recorded from the DAC. And then finally, getting to my own personal experiment. The higher the frequency, the amplitude decreased, but the wave looks similar to what it would look like as if it was near the microphone. So on the top right, you can see the 4 different frequencies as I dropped the phone, and you should have seen as it gets to the middle part between 0.1 seconds and 0.03 seconds, that the frequency should have increased because the phone should have been closer to the sound source. And as you can tell, it doesn't seem to do that. Then on the bottom right is what the frequency should look like as it gets closer. It should have the frequency should have increased. And yeah, and it didn't, unfortunately. So some possible errors. Possible errors could be user error, inconsistent tests, which because my phone could have fell in different ways because it started rotating, and then the audio jack again. In conclusion, at the furthest points of the drop, the perceived, which was 36 inches, the perceived frequency should have been at its highest value. My results said otherwise, and we know that cannot be. So this lesson that we can gain from this experiment was, while we did not achieve the results that we wanted, we know enough to know it was not correct. And the root cause, I think, was the biggest problem was most likely the fact that either microphone was too close to the drop or the sound was way too loud. So the possible solutions, perhaps next time I should have done the experiment at different volumes, progressively going up, just to make sure we know that those frequencies, the phone is quiet enough to where the microphone perceives that drop. And this concludes my lab report. Thank you.